In this slide, we are having here all conversion, all number system, decimal, binary, octal, hexa. Okay, it's just a table here, you can see. So see how we write in octal, as I told you earlier, in octal, if you are writing, so maximum is 0, 7. What happened after 0, 7? This list again change, continue. 0, 1, 2, 3, 4, 5, 6, 7. Except we just place here prefix 1. As we put here prefix 0, next prefix is 1. If I continue, so again, this list will be same 1, 2, 3, 4, 5, 6, 7, except this time prefix rather than 1, it is gonna be 2, 2, 2, 2, like that. So this is the way. Same happen in the decimal numbering also. 0 to 9, because we have digits 0 to 9. So prefix could be 0, or sometime we eliminate it, no need to write. Again, this listing will start from 0 to 9, and prefix will change this time 1. So this is the way to write numbering. In hexa also, 0 to 15 is the max. Oh, sorry, 0 to 5 F. What will be the next counting? If I ask you next counting after F, what will be the next number?
0, 1,
0, 1
to 2, so it's 20, 21.
No. After F, after this one, what I should write next if I want to write? Siva is saying G, Maria is saying G. So I will change hexa concept. Yes, Sukana, you are right. We know that hexa number system, the maximum is 0 to 9 and A to F. I cannot just put G from my side. I'm asking you how to write the numbering. So listing here. So after F, next is gonna be what? 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. What after 1, 9?
20.
Yes, until 1F, correct.
1A.
Up to 1F. What after 1F? What will be the next numbering count? Tell me.
20.
20, or
better
to say 20, because 20 will get you confused related to the decimal actually. That's why better to say 20, then 21, 22 until 29, then 2A, last will be 2F. Next count will be 2F. Next count will be 30. You know this one. This is the way to write the list there. This is the way actually. Okay, it's just for your information. It's not very big deal. Okay, next is what? Move to the addition, binary addition and all. Okay, fine. So this is decimal addition. What is the methodology basically? If I ask you girls, just add it. So what will be your answer?
110.
110 quickly, because we know addition in decimal. We can quickly give the answer. Okay, 5 it's a 0, and it is the next one will be carry. 1 plus 5 plus 5 is gonna be 11. So answer is 110. Okay, see how it is basically happening. The logic behind it actually it is. Girls, actually I cannot. I try to remove this sound, but I didn't get the option quickly. So maybe thunderstorm is there, huh? So 5 plus 5, the concept is that 5 plus 5. So because we are doing this addition in base 10, so we will check, is this result is greater than this 10 which we getting answer as a 10 is greater than equal to base 10 is greater than equal to, it is equal to base. If this is equal to base, subtract a base from the result. My result was 10, and if I subtract 10 from 10, what will be my result? 10 minus 10, 0. So 0 will be here and 1 will be carried. Correct? Because how many times I subtracted? I subtracted 1 time. So 1 will be here placed. Now I will do it again. 1 plus 5 plus 5. The result is 11. Okay, now check this condition. The 11, yani the result, is greater than equal to base? Yes. Yes. If yes, subtract the base from the result. Result is 11, base is 10. 11 minus 10 will give you 1. So 1 will be my result and next one will be my carry. Carry because I subtracted one time. Now we know that further there is no subtraction, so this 1 will come down. So my result is a 110. Okay, so this is what the methodology behind this subtraction actually, and why I explained to you, because I explained to you to make it generalized. And this concept is now applicable for other type of addition. If I talk in binary, if I go in hexa, octal, everywhere. Okay, now see next. Now in the binary, so if this come in the binary, if I ask you add them, so try to apply the same method. 1 plus 1, 1 plus 1. Think as a in decimal. Now think as a decimal. 1 plus 1 is what? 2.
2.
Okay. So what is the rule? We will check 2 is greater than equal to base.
Yes.
Yes. And what is the base? Base is 2. So if yes, subtract the result, subtract the base from the result. So 2 minus 2, 0. 2 minus 2, 0, and 1 will be carry. Okay, now 1 plus 0 plus 1. Now you need to add as a decimal only. You don't need to think about binary. Binary addition, maybe you know that 1 plus 1 is 0 plus 1 carry. Maybe you know that one. But from that concept which I just explained, I'm just trying to explain to you. Like 1 plus 0 plus 1, the result is 2. Check this condition again. 2 is greater than equal to 2. Yes. So 2 minus 2 will give me 0 result and 1 carry. Now 1 plus 1 plus 1. What is that?
3.
3. 3 is greater than 2.
Yes.
Yeah. So 3 minus 2.
It's 1.
1 carry. Okay. Now 1 plus 1 is a 2 again. 2 minus 2 will give me 0 with 1 carry. 1 plus 1 plus 1, it is gonna be 3. 3 minus 2 will give me 1 and 1 carry. 1 plus 1 is 2. 2 minus 2 will give me 0, 1 carry. This will come down. So here actually you don't need to think in a different way, just the binary, the decimal way. The 1 plus 1 plus 1 like 3. So this is the way. Now same thing, this method is applicable for the octal or other hexadecimal numbering system as well. Understand? So if you want to apply, see for example for octal, it is not there actually in your syllabus, but I am giving you idea. 4 plus 2 plus 1. Let's say I want to add 2 plus 1 plus 4. I want to add it. Okay, which is in octal. Must be clear. It should be mentioned in octal. So 1 plus 4, or let's say this is 7 plus 4. 7 plus 4 in octal. Do you have 11 in octal? No. So we will be applying the same concept which I explained to you. So 7 plus 4 is 11, and just add them in decimal. And after 11, you check it. Is this result greater than equal to
8.
Okay, yes. So 7 plus 4 is basically 11 in decimal and it is greater than 8. Yes, true, it is greater than. So we need to subtract 8 from the result, which is 11 minus 8. Okay, answer is 3. We subtracted one time, result will come here. So 1 plus 2, which is 3. 3 plus 1 is 4. 4 is less than basically 8. So no need to subtract anything. Just write 4 as it is. Now 4 plus 2, 6, which is still less than 8. So no need to subtract anything. So 4 plus 2 is 6. This is my answer. 643. Do you want to check it? You can check it. How can we check it? Just go open the calculator in the system. Use the octal and just check it. It will be coming like that. Is it clear? But this is not there in your syllabus. Any octal addition is not there. Only binary there. but for your idea, because this general method is applicable for all type of addition in number system. Maybe if you want to check it with the hexa, you can check it as well. All right, so this is the basic logic behind the addition. And this is, they are saying equivalent in decimal. This is 61 in decimal, another number is 23 in decimal. So when we subtract it, so we will be getting a result 84. Sorry, addition, sorry, we will be adding, so answer is 84, and which is, this number is also 84. If I want to check it, it is 84 or not, I can just check it with the help of weight. So it is what, 1, 2, 4, 8, 16, 32, next is 64. So just simple, you just, I can add it, 64 plus 32 plus, no, sorry, 32 I cannot use because it's a 0. Wait for once, yani 6, 4, that's it. Just add them. So it is a 484. All right. So this is the way. Now just move to next. This is about the subtraction, girls, in the binary. So subtraction is basically the concept comes here, which is borrow, you know, and borrow means whenever we take a borrow from the left side in a higher weighted digit, it comes as a base. Always borrow comes as a base. And what is the base of binary? 2. So whenever I ask a borrow to the neighbor left digit, it will give me 2. Okay, so see now. So 1 minus 1, what is the result?
0.
0. So 0 minus 1, possible?
No.
So what I should do? Take a
Should
borrow. Borrow from this one. So when this one give me borrow, how much it will give me?
2.
2, because of base. Same happen in the the concept in the decimal. Whenever I ask a borrow, it gives us 10. So here 2 will come. So now when the 2 will come, can I say 2 minus 1? What will be the result?
1.
2 will come here. All right. 2 minus 1 will give me 1 as a result. Now because this one already given a borrow to me, so how much it will be having? 0 or not?
Yes. So we
Okay.
have to borrow.
Yes, so we need to check it again, neighboring digit, or neighboring digit is also 1. So yes, it can give me borrow, but the point is borrow will come as a base, yani 2. So this is the updated value of this one. So 2 minus 1 will again give me 1. Now it is 0. So by the way, 0 minus 0. Yeah, we don't need further, borrow. So 0 minus 0 will give me 0. Now 0 minus 1, because we have still left digits, higher weights. So I'll ask from the neighbor one. So it will check with this 0. It is already 0. How it can give me borrow? So this will ask for the neighbor, please give me borrow. So that this one will give borrow to this one first. All right. So what is the weight of this 0 now? Updated weight 2. Okay. Now it will further give borrow to the next digit. So when it will give further to the next, it will be having deficiency of 1. Yani it becomes 1 because it has given 1 borrow, and borrow reaches here as a 2. All right, guys?
Yes.
Yeah, so 2 minus 1 will be 1, and 1 just come as it is down, and it is already 0. So this is what? Subtraction in binary with the concept of borrow. Okay, so it is one question is more than sufficient, and you can just try with yourself with this concept. All right, so this is in decimal 77, this is in decimal 23, and this is the answer 54. You can check it, your results, by weighted conversion. Next is multiplication. Multiplication is very simple. We know the concept, just apply the value. So this digit is need to multiply with all multiplicants. So when you multiply 0 with any digit, answer will be 0. Correct? Now, what is the rule? We need to shift left side and multiply by 1 with all. Is it clear, guys? Na?
Yes.
All right. Next digit is what?
Can you?
Okay. See, this is multiplication, which you know for the decimal. It's the same. The what is that? You will check this the rightmost bit and multiply with all. So the rule is multiply with this is the general rule actually. For decimal also we use the same way. So multiply 0 with all, answer will be 0. Okay. Next is what? We will multiply 1 with the others. So but you need to shift left side. You know that one. We will start here answers, not here. So we will leave it like cross. Sometime we put the cross. Maybe you remember that one. Huh? We will just put its cross, shift here. Now next is what? We put 2 crosses because we will shift again two times. Now we'll check it for that. So multiply with 0 now. This time we need to place 3 crosses. I will not consider these things. Now multiply with 1. Done. Okay. Now what is next? Just add them all. So it is about the addition. Already I explained to you how to add. Just you can use that one. So 0 is there, 1 is there, 1 is there, 0, 1, 0, 1, it's 2. So 2 minus 2 will give you 0, 1. Carry the same concept which I applied to you. You can use anything, that one or direct if you can add. So this is the answer. This is about what? Binary multiplication. All right. What next? So division is not there, only binary multiplication, subtraction and addition for the binary number, not for octal or hexa. All right. So it's not there in your course, but you can do, I explained to you with the general concepts. Okay. Okay, no problem. If you have 3 ones, 5, it's very simple. Let's consider we have one more one here. Let's say where? In any like here. So 1 plus 1 is 3. So 3 minus 2. Yes, Maria, you are right. 1 is the result, yani which is this is the result, and 1 will go carry because we subtracted 1 time. So 1 will be there. This is the way bus. Okay, fine. Clear? The rule is that if the result is greater than equal to 2, you need to subtract. Bus. This is the rule. All right. Now move to next. So girls, what we learn is just a summary of the conversion, basically number based conversion. So octal, binary and hexa. So we discuss here how to convert octal to decimal. The method is evaluate magnitude method, this one. Okay, magnitude evaluation. Another one is decimal to that one, decimal to base, decimal to that one. It is what? Division, successive division method and all. So this is all about I explained to you. Now coming to the complements. This is the basically the next topic. So do you need a break of short break, 5 minutes before starting complements?
Yes.
No, the short break we can have because I have spent much time. So inshallah, 5 minutes. Huh? 5 minutes okay? Okay. Yeah, short break. Actually, we need more time otherwise. We have to finish this chapter. All right, 5 minute break, inshallah. We'll be back in 5 minutes. Okay, girls. So should I start now? Okay, wait some time. One more minute. Yes, so can we start now?
Yes.
Yes.
All right. So let's start with the compliments. This is not that compliment, na? To praise someone, like you are looking something today. So it's not that compliment. This compliments in computer system is, is basically to represent a positive number as a negative. Hope that this is sounds new to you, the new information. In computer system, there is no subtraction hardware. It cannot subtract. Only thing is addition. There is an adder. It can add only all the time. It cannot subtract. Hardware I am talking about. So if I have a machine which can only add, so how can I perform subtraction? Are you getting my question? Yeah, Noor is saying something. Add a negative number. Yes, Noor, you are right. Absolutely. So it's about I have a machine which can add number. Yani, let's say I have number A and I am adding B. So addition is very simple. I can add them together. What if I want to subtract? So for the subtract, because I don't have hardware which can perform subtraction, so I will be using the same hardware. Same hardware. Yes, Sukaina, very good. Correct. Absolutely right. So we can say A plus minus B. So hardware is not changing. Hardware is same. Any operation is still addition, but we are representing this B as a minus B. This is the point. Very good, Sukaina, and yeah, Noor, you get the point. Basically, so now everyone hope understand now what I was trying to say. Hardware can add only, but how can I perform the subtraction? The way is if I can represent B, yani this number as a negative number. So for that reason, what we have here, how can we represent a positive number as a negative number? We can do it with the help of complements. So complements are used to simplify the subtraction operations, and they can basically represent a positive number as a negative number. So basically, girls, we have two type of complements. What are these? These are two, yani one is the base complement, another one is base minus one complement. Okay, so two types are for each base are for every base we have two kind of complement. One is which is called diminishing radix complement. Radix means you know that base complement, which is r minus 1. R stand for here base. So base minus 1 complement. Let's say if my base is 10, yani decimal. So base r is a 10. So I will be having 10 minus 1, yani 9's complement. If my base is 2, the complement will be 2 minus 1's complement means 1's complement. Similarly, another type, as I said, two type, another type will be R's complement. Here is R minus 1's, here is R complement. And what is R? Any base complement. Let's say if the base is 10, so I have 10's complement. If the base is 2, so it will be basically 2's complement. All right, guys. So this is the way. Now we'll learn one by one. So clear this one, guys? Complements. One is R minus 1, another one is R only. So it could be either 9's complement, 1's complement, 10's complement, 2's complement, or if we have another base, accordingly we have. So this is general rule. Two type of complement. One is called R minus 1, another one is called R complement. All right. Now move next. 9's and 10's complement. Okay. All right, yes. So 9's and 10's complement. How to get 9's complement? How to get 10 complement? I am explaining you here. See this one, guys. In order to have the 9's complement is applicable for the decimal. It should be clear to you. 10's complement is applicable for the decimal because the base is 10. So if I have this number, which is here mentioned, okay, and I want to get its complement, 9's complement. It is very, very simple. Just subtract all the digits of this number from 9. This is like that. Subtract all digits individual from 9. So 9 minus 3, 6. 9 minus 5, 4, and so on. Okay. Now, if you want to get 9's complement of this one, make sure you, if this is 0, so just put it like that. Count how many digits are there. 1, 2, 3, 4, 5, 6. So put here 6 9's. 9, 9, 9, 9, 9, 9, and then subtract it. So this is 9's complement. Okay. Now, if you want to get 10's complement, it is very simple. First get the 9's complement and just add 1. Just add 1. So I want to get this number 10's complement, which I already got it here, 9's complement. So I am going to just add 1 to this 9's complement and it will be simply this one. Or there is another direct way, which is that I want to get the 9's complement of this. So 6, 7, 4, 6, 5, 3. So the way is 9, 9, 9, 9, 9. And this will be 9 if you want to get 9's complement. If you want to get 10's complement, girls, if you want to get 10's complement, so do one thing. Rather than using here 9, just use here 10. So this is the direct method. Or else you can get first 9's complement, then add 1. Or if you want to get it directly, so just do it like that. Yani, just consider this is a 10. So 10 minus 3 is going to be 7. 9 minus 4 is going to be 4. 9 minus 6 is going to be 3. 9 minus 4 is going to be 6. 9 minus 7 is 2. 9 minus 6 is 3. So see the result. So directly is possible. Okay. So 9's complement. Now 10's will be, as I said, for the 10's complement, either you can get first 9's complement, which is here, just add then 1. Or as I explained to you, rightmost subtract from the 10. Rest all will be 9. So you will be getting direct 10's complement. This is about 10's complement. Now move to the next is, which is the one 1's complement and 2's complement. 1's and 2's complement are applicable for the binary numbering systems. So 1's complement of a given number, it is very, very simple. Let's say I want to get this 1's complement. So the way is, girls, either as I explained to you earlier, subtract everyone from the 1, 1, 1, 1, 1, 1, 1. You can get this one. It is little bit easy because we know that how to do subtraction, but I can give you more easy way. And what is the more easy way? You just see here, this is my number. Let's say, just a minute. Okay, the number is, let's say 1 0 1 1 1 0 0 1. I want to know its 1's complement. Girls, do one thing. Just flip the digits. Yeah, flip it. Replace 0 by 1, 1 by 0. Yani this 0 will be, this 1 will be 0, this 0 will be 1. This will be 0, 0, this will be 0, this will be 1, 1, this will be 0. One's complement. Just interchange 0 by 1, 1 by 0. This is one's complement. Okay. Now, 2's complement is that, girls, first get the 1's complement and just add 1. If I want to know its 2's complement, so for the 2's complement, I will simply add 1 and I will be getting 1, 1, 1, 0, 0, 0, 1, 0. It is 2's complement. Okay. Now, there is a one direct method to get the 2's complement. And what is that? I'll give it to you this, I'll tell you this one. So let's say I want to get the 2's complement of this number, which is there. 1, 0, 1, 0, 0, 0, 0, 0, 1, 0. Direct. I'm teaching you and telling you now, a direct method. So girls, copy this 1, 0 as it is. Copy this 1 as it is. So the point is, once you copy here, you continue copying until you copy the 1. Because I have just copy here 1. Further, I will not copy. So you keep copying from rightmost bit until you copy the 1. Once you copy the 1, stop copying. Now interchange or flip the bits. So 0 will be interchange 1, 1, 1, 0, 1, 0. Check your result here. Want one more example? Or clear? Yeah.
For 2 complement, flip and plus 1.
Yeah, you can do like that for 2's complement. First flip all, yani get the 1's complement. After getting 1's complement, just add 1 to the result. Then you will be having 2's complement. This is one way. Okay. Another way, I just explained this one. This is the shortcut method. So what is that one? I'll repeat this one with one more example. Let's say if I have this number, which number? 1, 0, 1, 0, 1, 0, 0. All right. I want 2's complement direct without getting 1's complement first, then adding 1. I'll copy this 0. I'll copy this 0. Should I copy again? Yes.
Replace.
Okay. So once you copy the 1 here, you will not copy further. You will replace. Yes. Yes. So once you just stop. Now after flip. So this 0 will be 1. This 1 will be 0. This 0 will be 1. This will be 0. This is 2's complement. Direct. Without getting first 1's complement and then getting 1. Okay. So whatever you like, you can use it. Direct 2's complement or get first 1's complement and add 1. Clear to everyone, girls? All right. Good. Now, so this is what I have already explained to you, the mathematics behind it in detail. So you can read it just. It's the same thing which I explained to you. Now, guys, this is the question which we are going to discuss about. Okay. Subtraction with complements of unsigned. Hope you know that numbers are signed and unsigned. Okay, there are two type of number system way of representation of the numbers. One is called unsigned, yani there is no sign. Another type is called signed. So there is some bit which represent the signed number. So I'll explain to you after this complement what are signed numbers, then you will understand. For now, this is unsigned, yani sign of the number is not mentioned inside it. It is not mentioned inside the bits, which is called unsigned. Okay. Now see, so we wanna perform this operation. Question is mentioned here. What is the question? Subtract 101, okay, minus 11, a minus b using 1's complement. So question will be like that. So it is mentioned here which complement method you will be using. Okay, so which complement it is mentioned? They are saying use the 1's complement method and subtract, perform subtraction. So when it is the case, you wanna use 1's complement method. So see the solution. So the thing is, 1 minute, let me spotlight. Okay, we will perform here actually a plus minus b, because we know that in computer system there is no subtraction operation. So here a is what? A is given me 101. What is b? B is given me 11. So what I will do, if I take the okay, let me just write separately this one for you. Maybe you will not consider. A is what given, girls? 101. What is b? B is given me 11. Okay, so what I will do, it means we are going to do this a plus 1's complement of b. A has 3 bits, you can see 1 2 3. B must have 3 bits, you can see here it has only 2. So b should be 0 1 1. This is the rule, you should note it down somewhere. Both number must have same number of digit. If it is having only 2, I need to consider 0 1 1. All right, now after that I have to take the 1's complement of this b. So 1's complement of 0 1 1 will be, you know that, just flip the digits. So 1 0 0. Now add. So we are going to perform a plus 1's complement of b. So a is 101 and 1's complement of b is 100. So just put it 100. Now add them together. So 1 plus 0 is 1, 0 plus 0 is 0, 1 plus 1 is 0 with 1 carry. So this is my result, 1001. All right, girls. Okay, can you check it? This in decimal, 101 in decimal, 5. 100 in decimal. Okay, no, don't check it here. Just a minute. We should check here, actually here. 101 is 5 minus 11. Do you know what is 11? Or 011, whatever. In binary, how much it is in decimal? 113, correct. So 5 minus 3 should be 2. I must have answer 2, correct. Now check it here. We here add, girls, what? This one, which is here, and we are receiving this result. Can you check what is this result? How much it is equivalent in decimal? 1001. It is 9. It is 9. Yes, no, it is 9 because this number is 9. So is this correct result? Result should be 2. But we are not getting correct. Okay. So there is some rules which must be applied here. And what is the rule? See, while I am adding these two numbers, 101, another one is 100, girls. So I just add them, 101, 000, 110 with 1 carry. So rule says whenever you have AND carry, this is called END, AND carry. Yani the carry which is coming at the end, if it is any carry, so there is a rule. Okay, what is the rule? Read here. After addition, if you have carry, then add the carry. Where to add the carry? C. So addition is 1001. This is my carry. What I will do, I will take 3 bits 001, yani this one, and I will add this one, last one, yani this one, to this result, yani add 1 carry. So my result will be 0, 1, 0 now. So here I have to perform 2-time addition. One is this addition, another addition is there because of this carry. Then I am getting this answer. Okay, what is this number? 0, 1, 0 in decimal. 2. So is it my correct result or not? This is my correct result. So there is a method, some methods we have to perform twice addition operation here, we have seen here. So but the thing is, the rule is very important. So the rule says if you receive AND carry, which is that one, we have to add this carry to our 3-bit result, which is 001, because my number is 3-bit, so it is my 001 is there, and we will add this one here. So 110, 1 will be carry, 111, and this. So this is my result. Now this is 2. Now girls, opposite is also possible. Yani this next example we are having, but we replace A by B. So now 11 minus 101. Okay, and 11 is what in decimal? 3 minus 5. Answer must be very good. Yes, minus 2. Now see here. So what is here for me? I have A is equal to 011 and B is equal to 101. All right, girls. Now, so what we are going to do here, one's complement of A, because we know that we are going to perform A minus B. So when I am saying A minus B, okay, so I have to take always B's one's complement, because subtraction is, B. So one's complement of B, which is 010. I will get it first. Now we need to add A plus one's complement of B, which is 011, yani which is this one, and this is one's complement, yani this one. Just add them together, girls. So when you add 1 plus 0, 1, 1 plus 1, 0, with 1 carry will come. So 1 plus 0, answer is 101. Now check it. 101 is what basically we know. What? 5. Yeah, but my result should not be 5. I should report, or I should display on the screen -2 rather than 5. So there is again rule comes here. So this previous rule was if there is an AND carry. But this time, do we receive a carry, girls, here? No carry. Why? Because 3 digit, answer is 3 digit. So I don't have any AND carry. So the rule says during the addition in complement method, if there is no carry, it means is that after addition, if there is no carry, means you are subtracting the larger number from the smaller number. Yani we are performing 3 minus 5. We are subtracting larger number from the smaller. So if no carry, it means you are subtracting larger number from the smaller. So how should I report my result? So answer should be negative, because we know that whenever we subtract larger number from the smaller, my result must be negative. So how I will be representing my result? I will represent my result in a way that I will display on the screen minus sign, and I will take one's complement of the result or the addition. The result was 101. So on the screen, I will display a minus sign. Also, I will take the ones complement of 101, which will be 010. Hope you understand. So negative sign will display on the screen, and 1010 is what? 2. So this will be displaying on your calculator or somewhere. This is my answer, yani minus 010. Clear to everyone, girls? Okay, very good. So girls, if you have notebook, please note this rule. If during the addition there is a carry, we need to add this carry to the number. If there is no carry, we need to represent negative sign and take the one okay, can you hear? Girls, can you hear me? Yeah, okay, okay. There is a resetting of the connection. It disconnected. Now it's connected. All right. So, okay. So we were discussing. Okay. So this is 2's complement, girls. Huh? I think screen is shared. Yeah, screen is shared. So, okay, just wait. Let me share the screen now. What about now?
Yes,
All
we
right.
can see it.
All right. Now, so guys, by using 2's complement, okay, so a little bit change in this method, but now see again. So 2's complement, subtract 101, okay, we are going to subtract 101 and from minus 11. Same question is same, but rather than 1's complement, we are going to perform 2's complement. All right. Now, so we will perform a plus minus b, means a plus 2's complement of b. Both the complements, either is minus 1's complement or 2's complement, are used to represent negative number. Okay, A has 3 bits, we can see here. B should also have 3 bits. So make it equal number of bits. This is the rule, very important, 0, 1, 1. Now, in order to get the 2's complement of this B, okay, let me just write what is A, what is B. So A is here 1, 0, 1 and B is here 0, 1, 1. So we will be getting 1's complement of the B first, which is 100. In order to get the 2's complement, just add 1. This will be the 2's complement. Or the rule, as I explained to you, get the 2's complement is you just copy this digit as it is. Once you copy the digit which is 1, you will not copy the next, you will just flip it. So 1 will be 0 and this 0 will be 1. You can match this, these two results are gonna be same. So method, what I explained, it's same. Okay, so our point is here to get the 2's complement. I got it here. Now add them, the result. A plus 2's complement of the B. Okay, so here A is 101, B is 101. Add them, 1010. Girls, this time I receive AND carry or not, because my result is 3 bit long, but my result is 4 bit long. So here I receive a carry. Okay, all right. So while you are performing subtraction operation in 2's complement, or I can say R's complement, because there are two kind of complement, R complement and R minus 1's complement. So R means the base itself. So this is 2's complement yani base complement. So if you are performing subtraction operation in R complement or let's say 2 complement, it means is that we need to discard the carry. Discard yani ignore the carry, means delete the carry. So I have extra bit here, which is this one now, this one. So what I will do, I will discard it. I will report my result as a 0, 1, 0 only. So read it here. After addition, if you have a carry, then discard the carry. So addition is this one. So this carry, which is at the end, leftmost, I need to ignore it, delete it. So my answer is 0, 1, 0. And it should be, because 5 minus 3 will give me 2 answer. And 0, 1, 0 is a 2 in decimal. All right. Now, next is just consider the same question, but interchange the A and B values. So this time A is 0, 1, 1 and B is 1, 0, 1. So get the 2's complement of this, which will be 0, 1, 1, and now add them. And girls, see this time. Are we having carry this time? No. So the rule is same which was for the ones complement. The rule says after addition, if there is no carry, means you are subtracting the larger number from the smaller number. So your answer should be negative. So what I will do, I will put a negative sign and I will take the 2's complement of the result. So put a minus sign, take the 2's complement of this one. So my answer, this is what they are saying. They are taking first 1's complement of this. 1's complement of this will be 0, 0, 1. Then add 1 to get the 2's complement. So my answer is this, minus 0, 1, 0. Yani minus 2. Yes. Clear, everyone?
Yes.
Yani the second rule is common for 1's complement and 2's complement. What is that? If there is no carry, it means is that we are subtracting larger number from the smaller number. So we have to put minus sign, okay, and take the complement back, because we are discussing a 2's complement. So get the 2's complement. Okay, so this is the concept of how to perform subtraction operation in complements. Okay, all right. Okay, some more examples, girls, you can see. So given the two binary numbers x and y, perform the subtraction x minus y and y minus x. Simple, using 2's complement. It is mentioned now. Mention, perform. So get x as it is, then get the 2's complement of y and get it here. So in this result, you see this one. So are we having here AND carry or not? Is this AND carry? AND carry, how would you know if there is AND carry? Means your result will be greater than that number of digits. So if there is an AND carry, what is the rule? While you are performing subtraction in 2's complement, remove it, discard it, absolutely. So very good. So just ignore what they are writing here. Discard the AND carry, 2's power 7, something like that. No need to just do this one. You can just focus on discard the AND carry. So my result will be this one only. Just report this one, right? My result is 0, 0, 1, 0, 0, 0, 1. Okay, what they are saying, this one and all, just leave it. No need for this one. Okay, you know that rule which I teach you just before, taught you. Just consider that. My result is this. Now y minus x. So you perform y minus x and you see that there is no AND carry. If there is no AND carry, you need, it means my result, what I have to place negative sign and take back 2's complement of the result, yani this one. So when I take the 2's complement of this one, it will be 1 will be copy as it is. Next one I will not copy because I have already copied. So flip. So 3 ones will replace with the 3 zeros. Then I have 0 here. It will be 1. Then I will be having 2 more zeros. So this is my result. That's it. Okay, so there will be some more questions you can just try in the book itself, or there are maybe next some we will be having some. Okay, this is what, same concept, same examples here, some examples. Okay guys, clear up to now? Complement clear? We used to have 10's complement, 9's complement, we have removed now, so you are just only 1's complement, second complements for you. Now second thing is that, as I told you girls, the numbers are basically signed numbers and unsigned numbers. So the examples which we were discussing, they were unsigned because the sign was not there. Now see what are signed numbers. So To represent a negative numbers, we need a notation for a negative values. Okay, in the system, when I want to save the data in a computer system in the memory, how memory will know whether the number is positive or negative? Because you know that how computers store the numbers or data, it is stored in the form of binary, which is 010101 like that. So in the computer, the data is in the form of 0101. If there is any number, so it will be in 0101. So how would it know whether this number is positive, this number is negative? So for that, we have signed binary number representation. See now. So it is customary to represent the sign with a bit placed in the leftmost position. Placed in the leftmost position of the number since binary digit. So computer cannot use minus plus signs. We know that it cannot just hold minus plus store inside the computer. It can store 0, 1 only. So in order to represent a number in sign magnitude, we must place a leftmost bit which will tell whether the number is negative or whether the number is positive. So the convention is to make the sign bit 0 for positive. If your number is positive, I will place 0 to the left, and if and we will use 1 for the negative number. Let's say example. So there are 3 different ways to represent a negative number. For the positive number, girls, there is no problem. Positive number is positive by default. But if I want to represent negative number, there are 3 different representations. What are these? First one, sign magnitude. Another one, 1's complement, which I just explained to you. Third one, 2's complement. Both 1's complement, 2's complement are used to represent negative number. Similarly, we have sign magnitude. I'll explain to you now one by one. So sign magnitude. In sign magnitude, the most bit is the leftmost bit is the sign bit always. So 0 is for positive, 1 is for negative. And the remaining bits hold the absolute magnitude. Remaining will be having absolute magnitude of it. Let's say I want to represent minus 47. Okay, with the help of 8 digits. Okay, so here we are using 7-bit for the magnitude itself, and the leftmost bit will tell the sign whether it is positive or negative. So see now 47. If you want to check it, 1, 2, 4, 8, 16, 32. This will be 64. We are reserving this column, yani this one, as a sign magnitude. Once you add them, you will know this is 47. But because I want to show negative 47, so the leftmost bit will be 1. It means this is negative 47. If it is a positive, all bits will be same. You check this column, same, 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 except the leftmost bit will be now 0, which is representing 47. And because of this minus 1, it is representing minus 47. This is sign magnitude representation of a number. Okay. Next one, these two you know already. 1's complement. So once replace each by 0 and 1 by 0. We know that this one. So here is what, if I want to represent minus 6. So in 8 bits I am using. So first I will write 6. So how do I write 6? 1, 1, 0. Correct? And we are using 8-bit numbering. So use 8. All will be 0, 0. Simple 8-bit. 6. This is what? Plus 6. I want to represent minus 6 in 1 complement. Okay. 1, 1, 1, 1, 1, 0, 0, 1. So this is what? Minus 6 in 1's complement. Khalas, this one. If you want to represent this one in 2's complement, okay, add 1 here, because we know that 2's complement is what? 1's complement plus 1. So when I do this one, it will be 1, 1, 1, 1, 1, 0, 1, 0. This is the way. So in next slide, you will see this one also. So 2's complement, this is the 2's complement. So what we conclude now, though there is a single representation of the positive, because positive will always be same whether we are using sign magnitude or complement, because complement is for the negative representation. But for the negative number there are three different ways: sign magnitude, one's complement, two's complement. Okay, although there is only one way to represent plus 9. So plus 9 will be same in all the complements, whether sign magnitude, one's complement or another one. But there are three different ways to represent minus 9 with 8 bits. Minus 9, sign magnitude. It will be represented like that. What is the change here, guys? Yani the last most will be negative, minus, 1 to represent the minus sign. Else is what? This one is what? 9, you know. This is what one's complement. So one's complement, as I explained to you, you will write first 9 in 8 bits. Then you will take one's complement 1, 1, 1, 1, 0, 1, 1, 0. This is 1. This is 2's complement. Is it clear to everyone? All right, so this is the negative binary numbers, how to represent. So three different ways to represent negative, but positive is gonna be same in all the representation basically. All right, so these are signed binary numbers, girls. This is decimal positive numbers, down is a decimal negative numbers. This is representation in sign magnitude. You can see this one, sign magnitude for the positive numbers which we are having here. See, these are all positive. So here the leftmost bit is always positive. For the negative numbers, the rightmost will always be negative. Ones and twos complement you already knows. I explained to you very well. So this is just a chart which is explaining this concept. Arithmetic in sign magnitude, girls. So signed binary numbers, arithmetic addition usually represented by two's complement. So this is important point here. While we are talking about signed numbers, previous was unsigned. So it is usually represented by two's complement. We always use two's complement rather than ones. We will not use one's complement here. So the addition of the two numbers in the sign magnitude system follows the rules of ordinary mathematics. We use the ordinary mathematics. What is that? Check it now, please. Read it. If the signs are same, because do you know, if two numbers are having same sign, what do? We add the two magnitudes and give the sum of the common sign. And what is the common sign? If both are negative, negative. If both are positive, positive. So we will give the same common sign. If let's say both numbers are positive, so we will give answer as a positive. If both numbers are negative, we will give sign as a negative. Is it clear? Like if I say -6, -4, what will you do, girls? You will add the magnitude, yani 10. What will be the sign? The common sign, which is negative. All right? Yes. Mashallah, you are getting good. So now another point is that, girls, if the signs are different, we subtract the smaller magnitude from the larger and give the difference, the sign, if the larger magnitude. Yani, if this is the case, for example, -6 plus 4. So what we do, ordinary mathematics, we see 6 and 4. So what we will do, we will perform 6 minus 4. My result will be 2. Now the sign will be the sign of the larger number. And what is the larger number? 6, which is negative. That's it. This is the rule basically. Okay. All right. Yeah, you got this point. Now the addition of two signed numbers with the negative numbers represent in two's complement from is obtained from the addition of this one. Carry out. Okay. Now see this one. +5 + 11. So how to write +5 in signed magnitude? We are talking about signed magnitude representation. Okay, so we will be writing, we are writing here with the help of 8 digits. So 5, we can write 5 like that. But because we are using 8 digits, we will be writing 8. Similarly, plus 11, we will be writing this way, this way. Add them together and this is your answer. Common sign you can see, plus is there. Now, another one is here. This is just to help you to understand. This is actual happening here. Minus 5. How do we write minus 5 in sign magnitude, girls? I told you already. Because this is 5. Okay. Now we have to take its, one's complement. No, not the one, sorry, 2's complement is mentioned, na? Always 2's complement. So the 2's complement will be this one. After getting 2's complement, 11 will be same actually. Just add them together. Once we add, my answer is coming this one. And we are getting here is carry. And do you know the rule in 2's complement? If there is a carry, discard it. We have to, ignore it. So my answer will be yes, correct. This is my answer. Similarly, next one is there. Okay, so you know this one, you can just read it now. So because I shortage of time, you can just read it now. Next bit remaining 2. Now, next is what? Binary codes. BCD codes. BCD, yani binary coded decimal. Okay, so what is binary coded decimal codes, girls? In BCD, a number, let's say if we have a BCD number with k decimals, yani let's say it is having k decimal, yani k number of digits. For example, if I am saying 396, so what is the value of k? 3, because k is representing, yes, why? K is representing the digits. So this is 3. Okay, will require 4k bits. 4k bits in BCD. What is 4k bits? 4 multiplied by the number of digits. Yani number of digits are 3. If I multiply 3 by 4, what will be my result? 3 by 4, sorry, 3 multiplied by 4 will give me 12. Yani I need 12 digits to represent 396 in BCD. Actually, what happened in BCD? That every decimal number uses group of 4, like in hexadecimal. Hope you remember, huh? So for 0 in BCD, we use 4 digits. For 1, we use 4 digits. So every digit uses 4 digits concept here. Because in decimal, we have 0 to 9 only. Okay, so our listing will be from 0 to 1001 only, not after that. Each digit individual representation. For example, now here it is 396, and I ask you, guys, represent in BCD. So what you will do? Same you did in the hexadecimal conversion. So you will write. You will write 3 by group of 4 basically. So you will say, okay, 3 will be teacher 0011. You will say for 9 separate 9 yani 1001. For 6 you will say 0110. 110. Now 4 plus 4 plus 4, 12 digits. As I explained to you, 12 digits. So in BCD, each digit represent individual as a group of 4. This is the concept here. Okay, guys. Hope it is clear to you. Now just continue one more concept here. So the binary combination 1010. Now so the point is, if I am using 4-digit combination, so I can generate 16 different combinations. I explained to you earlier. Yani we cannot stop here. We can continue, which is next will be 0010 and the last will be 1111. But in decimal, we have 0 to 9 only. We are not discussing hexadecimal. In hexa, we have 0 to 9, then we have A, B, C, D, E, F. But in here decimal, we don't have. So here is a point. Yani after 1001, the remaining combination is 0. Sorry, I'm writing here 0, 1010, 1011, 1100, 1101, 1110, 111. So how many combinations are there, girls? 6. 1, 2, 3, 4, 5, 6. Yes. So these 6 combinations in BCD, they are unused. We did not use it because in decimal, because BCD is what? Binary coded decimal. Yani decimal digits are coded into binary, because in decimal we have 0 to 9 only. So this is valid, but this is invalid. Yani A, B, C, D, E, F, which is in hexa, is invalid here. So this read this point. So the binary combination 1010 through 1111 are not used and have no meaning in BCD. They have meaning in hexa, but no meaning here in BCD. All right. Now, last topic I believe here is how to perform BCD addition. Addition in BCD. So consider a decimal number which is given to us, which is 185, and its corresponding value in BCD. If I ask you girls, this is a number and convert it into BCD. So it is very simple. You will say, teacher, it's very simple. I'll just make a group of 4. So 1 will be 0, 0, 0, 1. Next you will say 8, 8, 1, 0, 0, 0. Next you will say 5, 0, 1, 0, 1. By the way, you know that initial these 3 zeros, because all are 0, sometimes we ignore it. So this is BCD exact, and this is without consider. Sorry, this is okay BCD, no, don't ignore. Another one is what? Is the same thing, huh? What is that one? 1, 0, 0, 0. Okay. Here what they are saying? They are saying this is BCD, girls, and this is what? Binary. So in order to write in binary, concept is different. Binary, I explained to you, this is weighted 1, 2, 4, 8, 16, 32, and so on. Remember? So we write in binary this way. But in BCD, concept is exactly entirely different. Because in BCD, we write a group of 4, 4, 4 for each digit. Yani this one 8, 5, 5. If I wanna ask you convert this one decimal number into binary, what is the process? I hope you remember. If you wanna convert this one into binary, you will use successive division method. You will divide by 2 and keep noting. Then you will be getting this result which we are having here.